Okay, so a lot of people had questions on the homework from section 3.3, number 11 on page 121, I think, or 123. So this question, I'll just make a video and send it to everyone who needed help on it. So let's read it. For any planetary system, the orbital radius of planet R in meters can be predicted using the formula r equals kt squared to the power of 1/3. In this formula, k is a constant for the system and t is the orbital period of the planet. The value of k for the orbiting the sun is 3.37 times 10 to the 18th. If it takes Mercury 7.6 times 10 to the power of 6 to orbit the sun, what is the total radius of Mercury in meters? So in this question, we're basically trying to find the orbital radius, which is r, and they give us k, which is a constant right here, and they give us t, the time it takes for Mercury to orbit the sun, which is over here. Okay, so we plug in the value for k and t, and we solve for r, and then we just need to use some exponent rules. You could technically just put the numbers in and put it all into your calculator if you had a good scientific calculator, but we'll do it step by step. So let me put up my page here, and hopefully you can see this. So I wrote out the equation just like I was in the textbook, and I just plugged in the numbers. So k, it was this value, and this was t. It's written a little bit differently in the textbook. They have brackets, but I just put a multiply to show that this is really just one number, right? It's not two separate numbers that they have in the textbook. Um, so this is a simplified like scientific form where you don't have to write all the zeros. This number has a bunch of zeros on it. Okay. So first thing I'm gonna do is let's do some rules here. So we got this. This 2, the square, applies to the 10, and it also applies to the number as well. So you need to, here it's easy, power to power rule, you multiply 6 times 2 is 12, right? Here you're just gonna square the number itself on your calculator. So let's just do that first. Get out my calculator. So 7.6 times 7.6 gives you 57.76 times 10 to the 12 now, because 6 times 2 is 12. And close that bracket, and then everything else I'll just leave alone, so I can do it in the next step. Times 10 to the 18, and this is close equals r. Okay, so there we go. Now the next step here is this 1/3. It applies to everything. So remember the power to power rule. We're going to multiply again. 12 times 1/3. 1/3 goes to the 57.76. 1/3 goes to the 18. The 1/3 also goes to the first number. So here, 1/3 is something to the power of 1/3 is the same thing as finding the cube root of it. So like here, for example, side note. So if it was 57.76 to 1/3, oops, that's kind of squish, is the same thing as saying 57.76, right? So we're just finding the cube roots of these numbers. So you can use the exponent rule for the 10. So let's do the cube root on your calculator. Just type it out just like that. It should be a function. So the cube roots of 57.76, pulling out my calculator, 57.76, and cube root is 3.86, let's just say 3.86, and here 12 times 1/3, so 12 over 3, simplify 12 over 3 is 4, so 10 to 4. There we go. And then the other number, same thing, 3.37. What's the cube root of 3.37? Just write it like this into your calculator, but obviously 3.376 instead. 3.37 actually. And the cube root button, there it is, and it's 1.49 times 10, and then again the 18th. 18 times 1 over 3 is just like dividing 18 by 3, which is 6. There we go, and this is what r equals. Okay, next step is, again, these two have the same base, so you can just put them together. So we can say r equals something times 10. Remember, when you're multiplying exponents like this with the same base, you can just add it, 10 to the power of 10. And these two numbers you can just multiply together. So again, on your calculator, 1.49 times 3.386 equals, oops, 3.86 times 1.49. Okay, so you get 5.80. And I think that's the answer. Okay. Hopefully that kind of made sense. And take a look and let me know if you have any more questions.